Hello everyone. This video is on the course of Introductory Statistics and the topic of sampling methods. So in this video, I'm going to be working out of a free online textbook at openstacks.org, and it's their Introductory Statistics text. I am in section 1.2 called Data, Sampling, and Variation in Data and Sampling, and specifically working under the heading sampling, right? And I want to specifically talk about different methods of sampling. Right, so not going to read the whole thing, just get through some important stuff and get to the sampling methods here in a minute and explain them as best I can. So gathering information about an entire population often costs too much or is virtually impossible. Instead, we use a sample of the population, right, a subcollection. And this is key, right? It's in bold. A sample should have the same characteristics as the population it is representing. So we try to collect a sample so that that sample matches as well as possible the population we're pulling the sample from. Right, and then statisticians use various methods of random sampling in an attempt to achieve this goal. Alright, so this section describes some common methods of random sampling. And of course, each method has pros and cons, as they state. The easiest method to describe is called a simple random sample. A simple random sample. Any group of n individuals is equally likely to be chosen as any other group of n individuals if the simple random sampling technique is used. So they continue on, elaborate. In other words, each sample of the same size has an equal chance of being selected. For example, suppose Lisa wants to form a 4-person study group, herself and 3 other people, from her pre-calculus class, which has 31 members, not including Lisa. To choose a simple random sample of size 3 from the other members of her class, Lisa could put all 31 names in a hat, shake the hat, close her eyes, and pick out 3 names. That is probably the easiest way to get a simple random sample, just a random draw. Right, and they talk about a more technological way is for Lisa to first list the last names of the members of her class together with a 2-digit number, as shown here, and then use a table of random numbers found in many stats books and mathematical handbooks, or a calculator or a computer to generate random numbers. So for example, she generates these numbers here. Lisa reads 2-digit groups until she has chosen 3 class members, right? So 9, 4, 4, 3, 3, 6, 6, 0. Each random number may only contribute 1 class member. If she needed to, Lisa could have generated more random numbers, but random number generation is another way to produce a simple random sample, because it's pretty much the technological equivalent of picking names out of a hat. Right? Every member of the group, every member of the population has the same chance of being chosen for the sample. Also, every group of size n, right? Every group of size 3, every group of size 5 has the same chance of being chosen, right? So all groups of size 3 have the same chance of being chosen. All groups of size 5 have the same chance of being chosen with this method. And they go through a little thing here on using a calculator. There are plenty. You can also just look up online random number generators. They're easily available. And then some other well-known random sampling methods. The stratified sample, cluster sample, and the systematic sample. All right. So I will actually draw some pictures to go along with these, some simple pictures to explain these sampling methods. So to choose a stratified sample, divide the population into groups called strata, and then take a proportionate number from each stratum, which is the singular of strata. So they have an example there, but like I said, I would like to, on a piece of paper, oops, sorry, you don't want to see me. On a piece of paper, we're talking about a stratified sample. So imagine, a very simple picture. So imagine this box I'm drawing represents the entire population. And what we do to pull a stratified sample is we break the population up into groups. So let's say I break this up into these groups here. These 12 groups. So here is, stratum number 1, stratum number 2, and so on, all the way down here to, and again, it can be more than 12, less than 12 groups. This is just an example I'm making up. So here are these 12 strata. Right. Then, for the sample, I'll do some shading here. We're going to pull out from each strata about the same proportion of people, a proportion of members for our sample. So let's say I take from each strata about a quarter. Right, so everybody in that shaded box from strata 1 is in my sample. And I do the same proportion, or about an equal proportion, about a quarter. And again, it can be a quarter, it can be a third, a half, 1/10. Just so long as I'm pulling about the same proportion from every single strata, right? Every single stratum, sorry. And it doesn't have to be the same lower left corner, right? As long as I'm pulling about a quarter here, I'm pulling the same proportion or about the same proportion in every single stratum. All right, so the shaded regions equal my sample. All right. So I pull a bunch of them, a bunch of that. I pull from every single group, every single stratum, and that creates what they call a stratified sample. Now back in the reading, they give an example as well, right? For example, you could stratify or group your college population by department, math department, history department, English department, and so on. Those are the strata. And then choose a proportionate, simple random sample from each stratum. Right? So from each department, you pick some names out of a hat. You take the members of the math department, pick maybe a quarter of them or a third of them or whatever you want for the sample out of the hat, and then you pick about the same proportion of people out of a hat or a random number generator from the history department, the science, the biology department, the chemistry department, blah blah blah. Right? You do it for every single department in the college. Pull out about the same proportion randomly, and that'll create your sample. That's a stratified sample. Now for a cluster, right, the next method is called cluster sampling. To choose a cluster sample, divide the population into clusters or groups, which, is very similar to the stratified sampling. Right? It starts off the same way, so people very often confuse cluster sampling and stratified sampling. But let's see the difference. Divide the population into clusters, right, or groups, and then randomly select some of the clusters. All the members from these clusters are in the cluster sample. All right, so back on my paper again, right, this was stratified. You break it up into groups and take about the same proportion at random from each group, from each stratum. But in cluster sampling, we've got the same kind of picture. Right? So once again, suppose this big box I'm drawing, this big rectangle, represents the entire population. And then, as I did with stratified sampling, I break the population up into groups. So once again, I'll do 12 groups, right? Or 12, this time they're going to be called, clusters. So there's cluster 1, cluster 2, and so on, all the way to 12. Again, it doesn't have to be 12, be more than 12 clusters, less than 12 clusters, whatever that you decide when you're selecting a sample. Now, instead of pulling my sample, from each cluster, pulling a small proportion from each cluster, I pick a few clusters at random and take everything in those clusters and leave the other clusters, leave the other groups alone. So let's say I put these cluster numbers into a hat, or do a random number generator from 1 to 12. And I pull out, say I want a sample of 3 of these clusters, and I pull out 1, 7, and 12 at random, right? So I take everybody in cluster 1 to be in my sample, everybody in cluster 7 to be in my sample, and everybody in cluster 12 to be in the sample. And that's it. I leave the other clusters alone, right? So once again, the shading here represents the members who are in my sample. But you take entire clusters and leave other clusters alone to form your sample. Right? So not taking a little bit from each, like with stratified sampling. So try not to confuse those. So again, back here, their example, right? If you randomly sample 4 departments from your college population, the 4 departments make up the cluster sample, right? So, like the stratified sample they mentioned earlier, I break the college up into departments, math department, biology, chemistry, history, English, and so on. And then instead of taking a few from each, my sample is made up of the entire math department, and maybe the entire history department, and then the entire chemistry department, and that's it. I take everybody from a few departments and leave the rest of the departments alone. That's a cluster sample. All right, and then the final sampling method, not the final one. The final one that's actually considered a valid sampling method. We'll talk about convenience sampling in a second, but the final one that's considered a random sampling, an actual valid sampling method, is systematic samples. To choose a systematic sample, randomly select a starting point and take every nth piece of data from the listing of the population. All right. So once again, back in a little picture, So suppose, now this time I'm going to have the population be represented by a bunch of dots. Okay, so this is for systematic sampling. So let's say all these dots represent my population. Alright, so I'm going to pause this and draw a bunch. Okay. So I've drawn up here 30 dots. Alright, now I know populations are usually going to be bigger than this, but let's say all of these dots represent the population. So to create a systematic sample, I choose a starting point at random. I choose one member of the population at random. Pull the name from a hat, do a random number generator. So let's say this person's chosen here. Right? So they're in the sample. And then I just go every, nth element, as they said, where n can be a whole, any whole number. So let's say I want to go every third element after that. So this person, this object's in the sample, and then I go 1, 2, 3. This object's in the sample, right? So this is plus 3, right? Every third, and then 1, 2, 3, do it again. 1, 2, 3, do it again. There, and 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And, it's every third, right? And all these orange dots make up the members of my sample. And it didn't have to be 3, right? It could have been any number. I could have gone every 4 and then picked people for the sample. I could have gone every 5 and so on, right? But this is called systematic sampling. I pick a member of the population at random, and then from there, in some ordered list, go every third person, every fifth person, every eighth person, whatever, right, until I complete my sample. Okay. All right, and once again, they have an example here, right? For example, suppose you have to do a phone survey. Your phone book contains 20,000 residence listings, right? So the population is 20,000 people, 20,000 residents. You must choose 400 names from that sample. So number the population, 1 to 20,000, use a simple random sample method, just pick a number out of a hat or a random number generator. Pick a number that represents the first name in the sample. Then then after that, you choose every 50th name until you have a total of 400 names. You might have to go back to the beginning, of course, but, so I start with person 37, and then every 50 after that. I pick that person, then 50 later, pick that person, 50 later, pick that person. And if you get to the end and you still don't have 400 names, you start counting back from the beginning again. All right, the first number 1, until you get the 400 names. All right. Now this final sampling method is considered a not very good, or non-random. Most sampling methods that are considered valid sampling methods are random in nature. This last sampling method is non-random and therefore considered not all that valid, not a good way to collect the sample. But a type of sampling that is non-random is convenience sampling. Right, convenience sampling involves using results that are readily available. For example, a computer software store conducts a marketing study by interviewing potential customers who happen to be in the store browsing through the available software. Right, the results of a convenience sampling may be very good in some cases and highly biased, right? Biased means, to favor certain outcomes in others. This is considered, convenience because, those customers are already in the store. So there's a bias there, right? They already are customers, right? The study was supposed to be interviewing potential customers. So you're not getting a sample that represents the population very well, right? If you're trying to interview potential customers and you're just going to the folks that are already in the store, you're leaving a lot of the population unrepresented. You're leaving a lot of the population out when you perform, convenience sampling using data that are readily available, not random. Okay. All right, so now that I've gone over the different sampling methods mentioned in this section of this text, I want to take a look at some exercises. All right. So at the end of the section, at the end of the chapter, there's homework. Now, of course, there's problems involving other things from this section that I've brought up in other videos. I just want to get to the examples about the sampling methods, the problems about the sampling methods. So for instance, exercise 71 from chapter 1. The instructor takes her sample by gathering data on 5 randomly selected students from each Lake Tahoe Community College math class. What type of sampling was used there? So this instructor basically, took 5 randomly selected students from each math class. So we could think of these math classes as strata, right? They're groups. The population of math students is broken up into these groups, these classes. And then the instructor takes a few, right? Takes 5 from each class, from each stratum. This would definitely be stratified sampling. And I've mentioned this in other videos involving these OpenStax texts. Very often on the odd numbered problems, there's a link. You can click on the number. It'll take you to the solutions in the back of the text, and you see the answer they're giving is B. Click on it again, it takes you back, and you see B was what I said, right? Stratified sampling. All right. So another sampling method. Now this one doesn't have a solution, but I think we can still reason it out. Right. A study was done to determine the age, number of times per week, and the duration, or amount of time, of residents using a local park in San Jose. The first house in the neighborhood around the park was selected randomly, and then every 8th house in the neighborhood around the park was interviewed. This is an example of B again, the systematic sampling. All right. First, a house is chosen at random, and then the rest of the sample is selected by going every 8th house after that. That's systematic sampling. All right, and then in question 73, we're asked to state the sampling method ourselves. So part A, a woman in the airport is handing out questionnaires to travelers, asking them to evaluate the airport service. She does not ask travelers who are hurrying through the airport with their hands full of luggage, but instead asks all travelers who are sitting near gates and not taking naps while they wait. Now, of the ones we've discussed, this is not random. Right? This woman is not randomly selecting the people to hand this questionnaire out to. And the only method we saw that wasn't random was that convenience sampling. Right? She's doing this in a convenient fashion. People that are moving slowly through the airport are sitting and not napping. Right? She's not selecting those who are hurrying or are napping. Right? It is not a random selection at all. It is a convenient, readily available selection of a sample. Convenience sampling. Part B. A teacher wants to know if her students are doing homework. So she randomly selects rows 2 and 5 and then calls on all the students in row 2 and all the students in row 5 to present the solutions to homework problems to the class. This would be that cluster sampling. The teacher breaks up her classroom into rows, right? Each row is a cluster. And then she just selects row 2 and row 5 and takes all of row 2, all of row 5, and leaves the other rows alone. That was the cluster sampling. Part C. The marketing manager for an electronics chain store wants information about the ages of its customers. So over the next 2 weeks, at each store location, 100 randomly selected customers are given questionnaires to fill out, asking for information about age, as well as about other variables of interest. This is an example of the stratified sampling. Right? The population is broken up here into the stores, right? Store locations for this electronics chain. And it said at each store location, at each stratum, 100 randomly selected customers were given questionnaires. So the population is broken up into groups, strata, store locations, and then a sample is taken randomly from each group, from each store. That's stratified sampling. Part D. The librarian at a public library wants to determine what proportion of the library users are children. The librarian has a tally sheet on which she marks whether books are checked out by an adult or a child. She records this data for every 4th patron who checks out books. This every 4th, every 8th, every 3rd, right? This is that systematic sampling. Right? Systematic. And it looks like the final part here, and this will be the last one I do in this video. I think I've done enough examples, or read over enough examples of each. Hopefully they're understandable. Part E, a political party wants to know the reaction of voters to a debate between the candidates. The day after the debate, the party's polling staff calls 1,200 randomly selected phone numbers. If a registered voter answers the phone or is available to come to the phone, that registered voter is asked whom he or she intends to vote for and whether the debate changed his or her opinion of the candidates. All it mentions here is the words, 1,200 randomly selected phone numbers. Didn't really say how, right? So I would very simply call this a simple random sample. They must have had them generated somehow, either, again, pulling from a hat, using technology, generate these 1,200 randomly selected phone numbers and call them. So once again, we have A is convenience, B was cluster, C stratified, D systematic, and E simple random. Let's take a look. Okay. Convenience, cluster, stratified, systematic, simple random. Fantastic. Alright, so that's it for me. I am hoping that, having watched through this now, listened to me read and and explain examples to you, you understand these common sampling methods, common sampling techniques. The most basic one, the one you're going to see most often, simple random, right? Pulling names out of a hat, random number generation, just very simple. Every group of the same size has the same chance of being chosen. Stratified sampling, populations broken up into strata, groups, and then about the same proportion of people are taken from each group to make up the sample. Cluster sampling, the population's broken up into clusters, right? Also groups, but then just a few of those clusters are selected at random, and all those clusters are taken, and the rest of the clusters that weren't chosen are left alone. Then you have your systematic, where a starting point in the population is selected at random, and then every third person, every fifth object, every eighth object, whatever, every nth object after that is selected for the sample. And then finally, the worst of the bunch, right? The one that's not considered a valid sampling method, but it is used quite often, unfortunately. But it's not random, not a random sampling. It very often does not give you a sample that represents the population well, and that's convenience sampling, right? Where you just gather data that's readily available and is not random whatsoever. All right. So I hope this is all understood, and you have a easier time working on exercises, problems involving sampling methods in the future. And thank you very much for watching.